हरि करना।
So the fourth method in probability sampling for us is a cluster sampling. So cluster sampling is a probability sampling technique that involves dividing the population into clusters, selecting a random sample of clusters, and then sampling all individuals within the selected clusters. So this technique is useful when it is difficult or expensive to obtain a list of all individuals in the population. But it's possible to identify larger groups or clusters of individuals. So that's the reason a cluster sample, a probability sample in which each sampling unit is a collection of elements. Each sampling unit itself is a collection of elements. Before we have seen the element which exists inside a sample is known as a sampling unit, but when it comes to the cluster sampling, the sampling unit will become bigger. A cluster will become a sampling unit. So that's the reason we are saying each sampling unit is a collection of elements. So each cluster is a sampling unit here. I hope you got my point. So it's effective under the following conditions. Let me put it here so that it would be much easier for you. This is cluster sampling. Cluster sampling. So main point, a probability, normally a sampling unit is nothing but an element inside the sampling unit. An element inside the sample is known as a sampling unit. For example, if you have 50 people, 100 people inside a sample, then each person inside that sample is known as a sampling unit. But when it comes to the cluster sampling, so each cluster is an sampling unit. Each cluster is a sampling unit. So that is the reason a sampling unit with respect to the cluster sampling is a collection of elements. That's it. Okay, so now effective under, so on which condition cluster sampling would be effective? Say effective under the following conditions. One, a good sampling frame is not available or costly. While a frame listing clusters is easily obtained. And second one, the cost of obtaining observations increases as the distance separating the element increases. The cost of obtaining observations increases as the distance separating the element increases. So these are all about the cluster sampling. So now let's take a quick example to understand this better. So here let's select a Bengaluru. Now this is the Bengaluru periphery. Let's take this example. Now, suppose we want to estimate. Our target is to estimate the problem statement. Our target is to estimate the average income of households in a city. That's it. Pretty simple and straightforward problem statement. So now we want to estimate the average income of households in a city. Bengaluru, overall in Bengaluru district. Okay, in a Bengaluru district, we want to check this. Okay, now, but we do not have a list of all households in the city. Instead, we can divide the city or this Bengaluru into neighborhoods, select a random sample of neighborhoods, and then survey all households within the selected neighborhoods. That's what we are going to do. Okay, so now this is the Bengaluru. Now let's define the population. In this Bengaluru case, the population is all households in the city. Okay, let me write down here. Population is all households in the Bengaluru city. Okay. Now, so now we have to divide the population into clusters. That is our second step. So we divide the population into neighborhoods, with each neighborhood being a cluster. Okay. So here we are dividing this Bengaluru district into different sub uh, cities. They're basically we call it as taluk, or you can call them as sub cities here. So I have divided this into Kanakapura, then Ramnagaram, then Magdi, then Nilmangla, then we have Dodbalapur, then Devanhalli, then Hoskote, our place, then Ankel, and finally at the center Bengaluru city. So these are the subdivision I made for this Bengaluru periphery, overall Bengaluru periphery. So that's what the second step, second activity I have did it. So the first one, so step one is define the population, and step two is to divide the population into clusters. Done. Then, so once that is done, so now we need to randomly select clusters. But before that, I want to show you something. So now we have divided this into clusters. Kanakapura one cluster, Ramnagaram another cluster, Magdi, Nilmangla, Dodbalapur, Devanhalli, Hoskote, Anekal, Bengaluru city. Okay, these are the different clusters out of Bengaluru. Okay, so now each cluster will have households. So this is a Hoskote household, Bengaluru, and these are the households in the respective clusters. Done? Clear? Now we need to calculate the income of these households. Now I have certain clusters. Now what is the next step? What's the next step? Let's write it down. So next, step 3 is to randomly select clusters. That's it. So we use a random number generator, or we use a we will randomly select a sample of neighborhoods from the list of all neighborhoods in the city. So the size of the sample depends on the desired level of precision and the available resources. So here we will randomly select the clusters. So this is cluster 1, this is cluster 2, this is cluster 3, and once the clusters has been randomly selected, then you can directly do survey the respective subjects in that cluster based on requirement. Then survey all individuals within the selected clusters. That's the next step. The next step is to, once you have randomly selected the clusters, then the next step is to step 4. Step 4 is to survey all individuals within the selected clusters. Okay, that's what is our next step. So here for each selected neighborhood is nothing but the cluster. Here, host code is one cluster. So for each selected cluster, we survey all households within that cluster, and we collect data on the income of each household and record it. Now it's pretty straightforward. Step 5 is to calculate the estimate. Estimate is nothing but a statistic here. So average income of the samples. And then finally, step 6, interpret the results. So we interpret the estimate in light of the research question and the available data. We can draw conclusions about the average income of households in the Bengaluru district based on the sample data, taking into account the level of precision of the estimate and possible source of error. We'll put the interval. We'll put the confidence interval and we'll calculate. Okay. So this is the example that we have here. Okay. To make, I hope you got it. So this is what is called cluster sampling, and cluster sample, a probability sample in which sampling unit is a collection of elements. That's okay. So now let's take example. So this example we'll do it with the pandas. Okay. So as usual, let's anyway, pandas and numpy has been imported. Now let me create a data frame directly. Create a data frame with information on subcities or cities and households. Okay, so data is equal to pd dot data frame, and first let's take city. And let me name these cities A, B, C. These are the city names. D, E, F, G, H, I, J. So these are the cities. Now let's take the households. np dot random randint 50 to 100 for underscore in range of 10. So that's it. That's done. Then the second one, let's take the income this time. Income. Then np dot random dot normal. Let's go for the normal distribution here this time. Okay, normal, and from 50,000 to 1 lakh. That's okay. Yep, that's 1 lakh. So for underscore in range of 10, and it's closed. Okay, let's execute and cross check the data and see the data frame, and this is our data frame. You got the income, okay, and you got the 50,000 to the 1 lakh. Clear? So this is what is our income now. Then this is our data frame. Now let's select a random samples of neighbor or cities. Let's select a random sample of cities. So sample city is equal to data of city and sample sample of n is equals to 3. I'm going to go with the 3 value and random state, because I have how many? I have total 1 2 3 4 5 6 7 8 9 10. I have 10 clusters. Out of the 10 clusters, I'm going to select 3 clusters randomly. Okay, random state. Go for the random state. Go with the random state 1. Then come down and click on okay. Select all cities, select all households within the selected city clusters. That's it. So then our sample would be ready. So sample is equal to data of data and city and is in sample city. That's it. So our sample is ready. Let's view it now. Let me take this one exactly. Yeah, so that we'll have a clear picture of what is the difference. So now this is our study population maybe. Then we have taken, this is our sample. Let me put it sample. This is for us, it's cluster sampling. Let me write down a cluster sampling here. Cluster sampling, and this is just a sample. And here is your data set. You got the cluster sampling with the city. You see that C, G, J. Total 3 cities or 3 clusters were selected, and with 53, 57, 84, and then this one all together is called as obviously your sample. It's called a cluster sample. That's it. I hope you got my point. So out of these clusters, 3 clusters were randomly selected, and each household inside that cluster it will be counted or will be subjected to the survey, and the overall 3 clusters together make up a cluster sample. So this is what cluster sampling.